Picture the scene. It is the afternoon of April 19th, 1906. The cobblestones of the Rue Dauphine in Paris are slick, practically mirrored by a miserable, freezing, driving rainstorm. A man is walking down the street, holding an umbrella low against the bitter wind, his mind completely engrossed in complex, silent calculations. He steps out from behind a parked cab, right into the path of a massive horse-drawn military wagon. The horses rear up in the chaos. He slips on the wet pavement, and in a literal instant, the wagon's 6-ton wheel crushes his skull, ending his life right there in the mud. It is a brutal, sudden, and profoundly ugly conclusion to a life that fundamentally altered human history. Because the man bleeding out in the Parisian mud was Pierre Curie, a brilliant physicist, a Nobel laureate, and the mind that literally unlocked the radioactive secrets of the atom. Welcome to the shadows of history. Before we step out of the shadow of his incredibly famous wife, to peel back the layers of this misfit mind, his literal self-mutilating dedication to science, his shocking descent into spiritualism, and the explosive scandal following his death. Take a moment to like, share, and subscribe to Legendary Lives Unveiled. Your support allows us to keep bringing these hidden, tragic histories into the light. To understand how a Nobel-winning physicist eventually ends up hunting for spirits in dark, velvet-draped séance rooms, we must start with how his brain processed reality. Born in Paris on May 15, 1859, into a family with a deep medical and scientific lineage, Pierre never attended a normal school. His father, Eugene, a physician who had studied natural science, recognized the underlying reality of his son's cognitive architecture. The mid-19th century French educational system, specifically the lycées, was incredibly rigid, demanding rapid-fire recitation and rote memorization, where a teacher presented a fact and the student parroted it back instantly. Pierre's cognitive profile was the exact antithesis of that system. He possessed an intense, hyper-focused mind and was a slow, incredibly deep thinker. Forced into a rapid-fire environment, he would simply shut down. The traditional establishment, absolutely, would have labeled him a slow learner, or even intellectually deficient, mistaking his processing depth for a processing delay. But Eugene saw that Pierre was simply running a completely different operating system. He pulled his son out of the traditional path, homeschooled him, and made a pedagogical decision that literally altered the course of modern technology. Eugene focused heavily on something Pierre had a natural, almost savant-like affinity for: spatial geometry. Instead of forcing him to conjugate verbs at lightning speed, he let him study the three-dimensional shapes and the spatial arrangement of matter. This unconventional foundation trained his mind to visualize complex, multi-dimensional structures. By the age of 16, Pierre had earned a university degree in mathematics, and by 18, he held a license in physics from the Sorbonne. This spatial obsession paid off in a way that literally runs the modern world. In 1880, when Pierre was just 21 years old, he and his older brother Jacques started experimenting with non-conducting crystals like quartz, tourmaline, and a crystalline compound called Rochelle salt. They discovered a phenomenon they called piezoelectricity, a term originating from the Greek word piezein, which means to press. They found that applying mechanical stress to these crystals along very specific symmetrical axes generated an electric charge. To understand this, you cannot look at a quartz crystal as just a completely inert rock. You must visualize the atomic lattice structure, exactly as Pierre was doing in his head. In a piezoelectric crystal like quartz, silicon and oxygen atoms are arranged in a highly specific repeating pattern that crucially lacks a center of symmetry. In a resting state, the positive charges of the silicon atoms and the negative charges of the oxygen atoms are arranged so their central focal points perfectly overlap, canceling each other out to yield a zero net electrical charge. But when you apply mechanical stress, when you physically squeeze it, you deform that asymmetrical lattice. You force the atoms closer together, and because of the lack of structural symmetry, the positive charges are pushed slightly in one direction, while the negative charges are pushed in the opposite direction. You are literally prying the balanced charges apart, separating the centers of positive and negative charge to create a dipole moment. This displacement creates a voltage across the face of the crystal, converting mechanical energy directly into electrical energy. Imagine a wildly complex, perfectly engineered suspension bridge. In its resting state, the tension on all the cables perfectly balances the deck's weight. Nothing moves. But if the bridge is built with asymmetrical angles, pressing down hard on one specific node forces certain cables to pull sharply left and others to pull right, you are translating vertical mechanical stress into a horizontal directed flow. In the crystal, that directed flow is electricity. In 1881, the physicist Gabriel Lippmann applied mathematical thermodynamics to the Curie brothers' discovery, predicting that the reverse must also be true. Pierre and Jacques verified this experimentally, proving the reverse piezoelectric effect. If you apply an electric field to one of these crystals, it physically deforms, expanding or contracting based on the current. To measure these unbelievably microscopic electric currents, they had to invent a completely custom, profoundly sensitive instrument, the piezoelectric quartz electrometer. Every time you look at a digital watch, use the GPS on your phone, or rely on medical ultrasound technology, you are relying directly on the brain of a 19th century kid deemed too unconventional for regular school. Almost all digital electronic circuits today use crystal oscillators based on this exact principle, where a small electric current causes a tiny piece of quartz to vibrate at an incredibly precise, constant frequency, the foundational heartbeat of modern electronics. But Pierre wasn't satisfied with merely documenting the phenomenon. He became obsessed with the underlying rules of shape, structure, and balance that govern reality. In 1882, he took a position as the laboratory supervisor at the School of Physics and Industrial Chemistry in Paris, the ESPCI. Requiring unprecedented precision for his new investigations into the invisible forces of magnetism, he invented the Curie balance. This highly sensitive torsion balance utilized a microscopic wire to measure masses down to 0.01 milligrams based on minute twisting forces. Armed with this device, he spent years meticulously measuring how different materials reacted to magnetic fields at varying temperatures. Out of this grueling lab work emerged two monumental concepts. The first is the Curie point. He discovered that if you heat a ferromagnetic material like iron, which holds a permanent magnetic field, to a specific critical temperature, it undergoes a violent phase transition and completely loses its permanent magnetic properties. At the atomic level, in a ferromagnetic material, the magnetic moments of the atoms, their tiny internal compass needles, are aligned in the same direction, pointing north together. This alignment is driven by quantum exchange interactions that force neighboring atoms to parallel their spins. But heat is simply the macroscopic measurement of microscopic kinetic energy. As you heat the iron, you violently agitate those atoms, and the heat literally shakes the structural order apart. The thermal kinetic energy actively fights against the quantum exchange interaction. Once the critical temperature threshold, the Curie point, is reached, thermal kinetic energy overwhelms the alignment forces. The atomic compass needles spin wildly and randomly, transitioning the material from ferromagnetic to paramagnetic. This led to his second discovery, Curie's law, which states that for paramagnetic materials, magnetic susceptibility is directly proportional to an applied magnetic field, but inversely proportional to absolute temperature. Simply put, The hotter the material gets, the harder it is for an external magnet to force those wildly vibrating atoms back into alignment. The thermal chaos resists the imposed order. All of this heavy physics funneled into a moment of pure, elegant philosophy. In 1894, Pierre published a paper outlining the Curie dissymmetry principle, stating a phrase that still echoes in modern physics today. Asymmetry creates phenomena. The philosophical weight of this is breathtaking. If an environment is perfectly symmetrical, it is in a state of equilibrium. Nothing happens. A perfectly flat plane where air pressure is identical everywhere has no wind, because the air is perfectly symmetrical and static. Wind, a phenomenon, only occurs when there is an imbalance, an asymmetry between a high pressure and low pressure zone. Heat only transfers if there is a temperature gradient. A crystal only generates electricity if its lattice structure is inherently asymmetrical. Pierre articulated that physical reality, everything that happens, moves, or changes, is driven by imperfections. If symmetry is perfection, perfection is actually completely static and dead. It is the flaws and fundamental imbalances that breathe life into the physical world. The philosopher of physics, John Earman, takes Pierre's principle and applies it to modern quantum field theory, exploring how spontaneous symmetry breaking ultimately reveals the deepest truths of quantum mechanics. Earman uses the classic macroscopic analogy of the buckling rod. Imagine a perfectly straight, perfectly symmetrical metallic rod standing upright. Apply a perfectly symmetrical downward pressure to the top, and for a while, it compresses symmetrically. But at a critical threshold, the rod will suddenly buckle. Left, right, forward. The pressure and the rod are uniform, yet the buckling chooses a specific direction, becoming asymmetrical. Structurally, there is no asymmetry, which initially seems to completely break Pierre's rule. But Earman pushes this into the microscopic quantum realm to vindicate Curie. In classical physics, a vacuum is just empty space, possessing perfect symmetry because there is nothing to disturb it. But quantum mechanics tells us the vacuum is not empty. It's a bubbling soup of virtual particles constantly fluctuating in the lowest possible energy state, the ground state. Physicists discovered mathematically that the vacuum state itself can be degenerate. There isn't just one perfectly symmetrical bottom to the universe. Visualize the Mexican hat potential or the sombrero model. If you drop a marble exactly onto the peak of the hat, it is in a state of perfect symmetry. However, that central peak is highly unstable. The lowest energy state is actually the brim of the hat, the trough running around the center. Due to a microscopic quantum fluctuation, that marble will eventually roll off the peak and fall into the brim, instantly breaking the symmetry. The underlying laws of motion, the shape of the hat, are perfectly symmetric, but the ground state of reality, where the marble lands, is fundamentally asymmetric. When the universe cooled after the Big Bang, fundamental forces underwent spontaneous symmetry breaking. They fell into the brim of the hat, choosing a specific asymmetrical orientation that gave rise to electromagnetism, the weak nuclear force, and eventually gave mass to elementary particles. Pierre Curie realized decades before quantum mathematics were formalized that even the absolute nothingness of the universe has flaws baked right into its foundation. He was a solitary master of crystals, viewing the universe as an endless cascade of broken symmetries, a man who literally saw the architectural flaws of God. Profoundly isolated in his intellect at the ESPCI, Pierre was alone. But then, an asymmetrical human force entered his life, completely altering his trajectory. Marie Sklodowska. Their meeting in 1894 is a pivotal intersection in the history of science. Marie Sklodowska had emigrated from Poland to Paris to study at the Sorbonne. She was a brilliant physicist in her own right, desperately in need of laboratory space to conduct her research. A mutual acquaintance, the physicist Józef Kowalski, knew Pierre had space at his lab and formally introduced them. Pierre was absolutely captivated, not just by her physical presence, but by an intellect that mirrored his own intensity. He wrote to her, urging her to join him in what he called our scientific dream, articulating that every discovery, however small, was a permanent gain for humanity. They married in 1895, right as their union collided with a massive scientific paradigm shift. In 1896, the physicist Henri Becquerel accidentally discovered that uranium compounds were emitting mysterious, invisible rays that could expose photographic plates even when wrapped in thick black paper. Becquerel initially thought these rays were a form of invisible luminescence triggered by sunlight, but he soon realized that uranium emitted this energy spontaneously, in total darkness. The scientific community was intrigued, but quickly moved on, dismissing it as a minor anomaly. Marie Curie, however, decided to investigate these mysterious rays for her doctoral thesis. She didn't just look at pure uranium. She began examining pitchblende, an incredibly complex, dense, highly radioactive mineral ore. Utilizing the highly sensitive piezoelectric electrometer that Pierre had invented 15 years prior, she measured the electrical conductivity of the air around the pitchblende caused by the radiation and calculated the amount of uranium present in the ore. But the mathematics demanded an explanation. The electrical charge she measured was 4 to 5 times higher than could be accounted for by the uranium alone. She formulated a bold hypothesis. There must be another completely unknown, highly active element hidden deep within the complex chemical matrix of the pitchblende. It is here that Pierre Curie makes a staggering intellectual and professional sacrifice. As an established, highly respected physicist with his crystal electrometer, his groundbreaking work on magnetism, and his profound symmetry principle, he instantly recognizes the magnitude of her data. Without hesitation, he completely abandons his own beloved lifelong research to join her crusade into the unknown. We must acknowledge the grim physical reality of their legendary workspace. Known in scientific lore merely as the shed, it was actually an abandoned, dilapidated structure at the ESPCI that had formerly been used as a medical dissecting room. It possessed a dirt floor, a glass roof that leaked constantly when it rained, and was freezing in the winter while acting as a suffocating oven in the summer. In this utterly inadequate, miserable space, they embarked on the brutal process of chemical fractionation to isolate the unknown element, utilizing tons of waste pitchblende sent by the Austrian government from the mines in Joachimsthal. They systematically dismantled tons of ore, molecule by molecule. This was backbreaking industrial-scale labor, boiling massive vats of pitchblende in strong acids, inhaling highly toxic hydrogen sulfide gas, and using heavy iron rods almost as tall as Marie herself to stir boiling caustic liquids for hours on end. Their method of fractional crystallization relied on slight differences in solubility to separate the radioactive elements from the inert barium present in the ore. Because barium chloride and the hypothetical new element's chloride had slightly different saturation points, they would dissolve the materials in boiling water, let the solution cool, and wait for crystals to form. The slightly less soluble radioactive element would crystallize first. They would separate those crystals, dissolve them again, and repeat the process thousands of times. They were essentially performing microscopic chemical surgery using sledgehammers and boiling acids. The persistence yielded unimaginable results. In July 1898, based on the radioactive signatures in their chemical fractions, they announced the discovery of a new element, polonium, named in honor of Marie's politically oppressed homeland. Just months later, in December 1898, They announced the discovery of radium, an absolute revelation that is roughly 1 million times more radioactive than uranium. They were isolating and processing this hyper-concentrated material with absolutely zero protective gear or any understanding of the biological consequences. The physical toll was brutal, immediate, and compounding. Handling highly radioactive concentrates with their bare hands, their skin was constantly raw, inflamed, and cracking. They suffered from profound chronic fatigue, bone aches, and respiratory issues, symptoms medical science now recognizes as the early acute stages of radiation sickness. Yet, they were totally mesmerized. The radium salts were spontaneously luminous, and the radiation exciting the surrounding air literally caused the jars to glow in the dark. They would visit the drafty shed at night simply to sit surrounded by these ethereal, blue-green glowing vessels, viewing them as the physical manifestation of the invisible energy they sought, the ultimate triumph of pure science. Pierre actively investigated the physical properties of this radiation. Utilizing his deep expertise in magnetic fields, he applied the Lorentz force principle, the law that a magnetic field exerts a force on a moving electrical charge, bending its trajectory. By passing the radium emissions through powerful electromagnets, Pierre observed that the radiation was not a single uniform ray. It split into 3 distinct physical pathways. One portion bent slightly, indicating heavy, positively charged particles. Another bent sharply in the opposite direction, revealing very light, negatively charged particles. A third portion remained completely unaffected by the magnetic field, passing straight through with no electrical charge at all. Pierre Curie was physically mapping the fundamental architecture of atomic decay, providing the foundational evidence for what Ernest Rutherford would later formally classify as alpha radiation, beta radiation, and gamma radiation. But the pursuit of this knowledge led Pierre to an act that blurs the line between profound scientific dedication and terrifying self-mutilation. A deeply rational thinker, Pierre voluntarily took a sample of highly concentrated radium salts, strapped it directly to the bare skin of his arm, and left it there for 10 hours. He intentionally inflicted a severe necrotic radiation burn upon himself. Over the ensuing weeks and months, he meticulously measured, observed, and documented the biological evolution of the lesion, recording the initial erythema, the severe blistering, the deep ulceration of the tissue, and the incredibly slow, painful scarring process. He literally turned his own body into a disposable petri dish. Through this agonizing act, he observed that the invisible radiation was actively and systematically destroying living cellular tissue. This realization sparked a brilliant hypothesis. If the destructive power of this asymmetry could destroy healthy tissue, could it be directed to selectively destroy diseased tissue, like tumors? He immediately initiated collaborations with medical professionals at the St. Louis Hospital in Paris. Pierre Curie's deliberate self-mutilation directly birthed the field of Curie therapy, the direct ancestor of modern radiation therapy, and the foundation of oncological treatment. He sacrificed his own cellular integrity to prove a medical concept that has saved millions of lives. The suffering they endured yielded the greatest scientific accolade in the world, the Nobel Prize. However, the overwhelmingly male-dominated scientific establishment almost immediately attempted to erase Marie from the narrative of her own discovery. In 1903, the French Academy of Sciences drafted the official nomination for the Nobel Prize in Physics, nominating Henri Becquerel and Pierre Curie, but completely and intentionally omitting Marie Curie's name. Fortunately, they had an ally operating in the shadows, the Swedish mathematician Magnus Gösta Mittag-Leffler. A strong advocate for women in the sciences with access to the nomination files, Mittag-Leffler secretly sent a back-channel communication tipping Pierre off aimed to the Academy's deception. Pierre's reaction was swift, furious, and utterly uncompromising. In August 1903, he wrote a blistering letter back to Leffler, explicitly stating that he wished to be considered, together with Madame Curie, with respect to the research on radioactive bodies. He declared that an award failing to acknowledge her foundational role would be an absolute travesty. Strikingly, he wrote that it would be artistically pleasing to keep their names associated. Even in the heat of defending his wife against blatant institutional sexism, his mind went to symmetry. An award lacking her name would be an asymmetrical representation of the truth, and therefore scientifically and artistically ugly. He issued a direct ultimatum: include Marie as a joint recipient, or he would publicly refuse the prize. Through Pierre's fierce advocacy and Leffler pulling immense diplomatic strings behind the scenes, the committee was forced to amend the nomination. In December 1903, the Nobel Prize in Physics was awarded jointly to Henri Becquerel, Pierre Curie, and Marie Curie, making Marie the first woman in history to win a Nobel Prize. Yet they were too violently ill from radiation sickness to even attend the ceremony in Stockholm. They couldn't make the journey until June 1905, where custom dictated that the male laureate deliver the mandatory address. In his Nobel speech, Pierre meticulously outlined the division of labor, clearly distinguishing between his contributions and Marie's independent foundational work, forever cementing her legacy on the public record. Then, he delivered a chilling, highly prophetic warning. He directly compared radium to Alfred Nobel's own invention, high explosives, warning that in criminal hands, radium could become a terrifying weapon. Decades before the Manhattan Project, or the horrors of Hiroshima and Nagasaki, Pierre posed a deeply philosophical question to the gathered scientific elite. Is humanity mature enough to benefit from knowing the ultimate secrets of nature? Or will this knowledge inevitably lead to our own destruction? Extrapolating the thermodynamics of atomic decay, he intuitively foresaw the catastrophic moral implications of nuclear energy, seeing the shadow of the nuclear age long before anyone else. He is a profoundly rational, ethical, and relentlessly logical physicist, which makes the final, bizarre phase of his life so incredibly jarring to reconcile. Because while Pierre Curie was mapping the architecture of the atom and warning humanity about nuclear devastation, he simultaneously became consumed with an obsession to unlock the secrets of the dead. In the early 1900s, crossing the boundary into the world of spiritualism, Pierre Curie formally joins an elite research group at the Institut Général Psychologique in Paris. And he isn't a lone eccentric in this pursuit. He is sitting in dark rooms alongside titans of intellect: the Nobel laureate physiologist Charles Richet, his own brother Jacques Curie, and the renowned astronomer Camille Flammarion. They are all gathering to study a fiery, deeply controversial Italian medium named Eusapia Palladino. Palladino was a global sensation. She was a peasant woman who claimed to be the earthly conduit for a spirit guide she called John King. She held highly theatrical séances where heavy wooden tables would violently levitate. Accordions and mandolins would play themselves while floating across the room. Glowing, disembodied hands would materialize from the darkness to touch the faces of the investigators. The historical record is brutally clear here. She was a massive, documented fraud. Exposed multiple times by skeptical researchers in Britain and America, Palladino was caught repeatedly using strands of her own hair to manipulate sensitive scales. She perfected a technique of slipping her foot out of her shoe in the dark, so the investigators believed they were securely holding her foot down while she actually used her free leg to kick the table into the air. And if the scientists started looking too closely at her physical constraints, she would flirtatiously throw herself into the laps of the male investigators just to shatter their concentration. Yet, these brilliant French scientific minds, Pierre Curie among them, kept returning to her séance table. To understand why, we have to examine his methodology. Pierre did not approach these séances as a grieving individual seeking religious comfort. He approached the séance room with the exact same ruthless empirical rigor he applied to his crystallography lab. He treated the haunting as a mechanical engineering problem, establishing the séances as strict scientific experiments. He brought in acoustic measuring devices to track the sound waves of the spirit raps. He set up magnetometers to detect fluctuations in the room's magnetic field when the table levitated. He wired her up to rudimentary medical equipment to monitor her blood pressure, respiration, and muscular reflexes during her supposed trances. He was literally trying to mathematically quantify the paranormal. Why would a Nobel-winning physicist waste his time measuring a known trickster? The answer lies in the profound epistemological break that had just occurred in physics between 1895 and 1900. Put yourself in Pierre's mindset. He had just witnessed the discovery of X-rays, invisible waves that could pass right through solid human flesh to reveal the skeleton. He had mastered magnetic fields, invisible forces that could bend solid metal. And he and Marie had just discovered radioactivity, heavy rocks that spontaneously, infinitely emitted invisible energy capable of destroying living tissue. When viewed through that lens, the boundary between physics and magic had completely dissolved. If you have already accepted that a lump of pitchblende can glow in the dark with tissue destroying infinite energy, is the concept of a spiritual telegraph, an invisible energetic resonance communicating across spatial planes, really that much crazier? To a mind primed by the discovery of radioactivity, the paranormal no longer seemed supernatural. It seemed like a frontier of physics that simply hadn't been formalized into mathematical equations yet. Pierre hypothesized that the phenomena Palladino produced, the kinetic movement of tables, the glowing lights, might be the macroscopic manifestation of an unknown bioenergy, perhaps intimately related to the invisible subatomic energy hidden within the atomic nucleus. But here is the massive twist in the narrative. Despite knowing she used sleight of hand, and despite the rigorous scientific controls and magnetometers, Pierre Curie became a full-fledged believer. The historical materials contain a deeply revealing letter he wrote to his close friend, the physicist Georges Gouy, dated April 14, 1906. This is just 5 days before his death. Pierre wrote that after all the controlled experiments, he was forced to conclude that, and I quote, "These phenomena really exist, and it is no longer possible for me to doubt it." He hypothesized that they represented an entirely new physical state, in space of which we have no conception. Utterly convinced he was standing on the precipice of an intellectual revolution, he believed he was going to integrate the paranormal into the established laws of thermodynamics. Literally drafting protocols for methodical, rigorous experiments to map this new physical state of space was an absolute genius, a man who broke the atom, simply duped by an Italian con artist who knew how to slip out of her shoes? Or is the deeper truth that pure, unadulterated scientific curiosity requires a mind to investigate the seemingly impossible without the prejudice of the establishment? Pierre was willing to risk his entire scientific reputation, risking absolute mockery from the academic establishment, simply because the raw data, as his instruments measured it, demanded an explanation. He refused to dismiss an anomaly just because it was uncomfortable, but he never got the chance to write the equations for that new physical state. Because exactly 5 days after writing that letter, asserting the existence of spirits, we arrive back at the horrific tragedy of April 19th, 1906, the freezing rain, the wet cobblestones of the Rue Dauphine, the slip, and the massive, unyielding weight of the military wagon. A sudden, violent, permanent asymmetry. A 6-ton wheel ends the life of Pierre Curie at the age of 46. The impact on Marie was catastrophic. Petrified by grief and emotionally shattered, she fiercely refused the French government's offer of a state pension for widows, insisting she was capable of supporting her children herself. Then, in a monumental, historic pivot, the University of Paris offered her Pierre's vacant academic chair. She accepted, becoming the first female professor in the history of the Sorbonne. While she assumed his public mantle, her internal psychological landscape was devastated. She maintained a private diary where she continuously wrote agonizing letters directly to Pierre. It reads as a heartbreaking, desperate echo of their shared investigations into spiritualism, trying to maintain that spiritual telegraph with the consciousness she had lost, refusing to accept that his mind had simply vanished into the mud, which makes the final chapter so incredibly explosive. It completely shatters the solemn reverence of her widowhood. Fast forward to 1910 and 1911. Marie is a widow in her early 40s, and she eventually finds profound intellectual and emotional solace in the arms of a man named Paul Langevin. He was a brilliant theoretical physicist, but more importantly, he was deeply connected to Pierre's legacy. He had been one of Pierre Curie's star pupils and had even collaborated with Pierre on the early development of sonar technology, utilizing those exact same piezoelectric quartz crystals Pierre had discovered decades earlier. Langevin was deeply embedded in the inner sanctum of the Curie intellectual circle. The friction arises from Paul Langevin's domestic reality. He was married, with 4 children, to a woman named Jeanne. The historical documentation makes it very clear that it was a deeply unhappy, volatile, and terribly mismatched marriage. Langevin complained bitterly that Jeanne was physically and emotionally abusive, repeatedly showing up to his laboratory bearing bruises, claiming she had assaulted him with a chair during domestic disputes. Jeanne, conversely, harbored deep resentment that Paul prioritized his poorly paying, esoteric scientific research over providing a lucrative, stable financial living for his family. The household was a powder keg. Seeking refuge from this domestic warfare, Paul found intellectual parity and emotional warmth with Marie. They rented a secret apartment near the Sorbonne to conduct their affair away from prying eyes. But Jeanne Langevin was intensely suspicious. She hired investigators, intercepted their mail, and eventually broke into a desk to discover highly intimate love letters between Marie and Paul. These missives included letters where Marie explicitly advised Paul on the legal and emotional tactics he should use to demand a formal separation from his wife. Armed with these letters, Jeanne launched a campaign of blackmail against Marie. When Marie refused to yield, Jeanne leaked the letters to the press. A private romantic entanglement detonated into a massive, highly politicized national scandal. To understand the sheer ferocity of the public reaction, we have to look at the deeply, violently polarized political climate of Third Republic France, still reeling from the cultural trauma of the Dreyfus affair. On one side, left-wing intellectuals, scientists, and progressive newspapers vehemently defended Marie's right to a private life, viewing the attacks as anti-intellectual and deeply misogynistic. On the opposing side, conservative, right-wing, and nationalist publications seized upon the affair to launch a brutal xenophobic campaign against her. The nationalist press attacked her not just as a homewrecker, but as a dangerous foreigner. They published virulent headlines, falsely claiming she was Jewish, deploying deeply anti-Semitic tropes to frame her as a corrupting foreign element, eroding the moral fabric of a good Christian French family. Some extremist papers even propagated the horrific, entirely baseless conspiracy theory that the affair had begun while Pierre was still alive, and that Pierre had intentionally thrown himself under the wagon in despair over her infidelity. It was character assassination on a national scale. The scandal reached a fever pitch while Marie was out of the country, attending the legendary 1911 Solvay conference in Brussels. She was sitting at a table alongside Albert Einstein, Max Planck, and the greatest minds of the century, debating the bleeding edge of quantum physics. Simultaneously, a nationalist editor named Gustave Terry published her private, intimate love letters in his magazine, plastering her private affections across the newsstands of Paris. The fallout when she returned to France was visceral and genuinely dangerous. She arrived at her home in Sceaux to find an angry, violent mob surrounding the property. They were hurling stones at the house, screaming xenophobic slurs, literally terrorizing her 14-year-old daughter Irene and her 7-year-old daughter Eve. The situation was so physically threatening that they had to flee with the help of friends and hide in secret locations across Paris. The scandal even permeated the highest levels of the scientific establishment. The Swedish Academy of Sciences had just announced they were awarding Marie a second Nobel Prize, this time in chemistry, for her work isolating pure radium. However, upon reading the Parisian tabloids, a member of the committee wrote to her, cowardly suggesting she voluntarily declined to attend the ceremony in Stockholm to avoid embarrassing the Swedish king with her presence. Marie, channeling that exact same uncompromising, fierce spirit Pierre had demonstrated in 1903, penned a chillingly rational reply. She stated that the prize was awarded for the discovery of radium, a scientific fact, and that there is no connection whatsoever between her scientific work and the facts of her private life. She refused to yield. She traveled to Stockholm and accepted her second Nobel Prize. Meanwhile, back in the streets of Paris, the tension literally culminated in violence. Paul Langevin, enraged by the public defamation of Marie's character, formally challenged the journalist Gustave Terry to a duel, a literal duel. They met at dawn at the Parc des Princes cycling stadium, facing off with loaded pistols at 25 paces. A shootout over the legacy of the Curie name. Thankfully, it ended as a bloodless duel. Both men, perhaps realizing the absurdity of dying over tabloid gossip, refused to fire their weapons. But the spectacle vividly illustrates how Pierre's death had shattered the insulated, protected world of the laboratory. Without Pierre's steadying presence and respected status as a native Frenchman, Marie was entirely exposed to the viciousness of public opinion, xenophobia, and the rigid, unforgiving moral judgments of early 20th century society. The affair between Marie and Paul eventually dissolved under the crushing weight of the scandal, and Paul returned to his wife. But the historical sources provide one final, deeply poetic footnote to this explosive saga. Fast forward several decades. Pierre and Marie's granddaughter, Hélène Joliot-Curie, who herself became a highly distinguished nuclear physicist, fell in love with and married a man named Michel Langevin. Michel Langevin was the grandson of Paul Langevin. It is an incredible, almost gravitational full-circle moment. The legacy of Pierre Curie isn't merely contained within the equations of quantum mechanics or the radiation treatments in modern hospitals. It is woven into the enduring, inescapable pull of the families involved. The physics of their lives kept pulling them back together across generations. When we synthesize everything, the crystals, the magnetism, the radiation, the séances, the tragedy, and the scandal, and connect it back to Pierre's overarching philosophy, a profound narrative cohesion emerges. Pierre Curie built his entire scientific worldview on the dissymmetry principle, the fundamental truth that phenomena, change, and reality itself only exist because of flaws, imbalances, and broken symmetries. A perfectly symmetrical universe is static. It is dead. It's the asymmetry, the flaws, that create the sparks of existence. When we view his tragic death and his bizarre, desperate search for ghosts in his final days through that lens, a totally new interpretation arises. Perhaps his presence in those dark séance rooms wasn't a lapse in scientific judgment or a descent into madness. Perhaps it was his ultimate philosophical rebellion against the permanence of death. What if, in Pierre's fiercely visionary mind, the human soul was simply the final, unbroken symmetry waiting to be mathematically discovered, a state of perfect, infinite equilibrium that we only return to when the chaotic, asymmetrical phenomenon of a human life finally comes to a crushing end? The soul as the final, unbroken symmetry. It is a concept that fundamentally reconfigures how you look at the boundary between life and death. I want to ask you, our listener, to really consider the physics of your own reality. Keep questioning the invisible forces in your own lives. What underlying imbalances, what foundational asymmetries are creating the reality you experience every single day? If you enjoyed this exploration into the brilliant, bizarre, and deeply tragic life of Pierre Curie, make sure to like, share, and subscribe to Legendary Lives Unveiled. We really rely on your interactions to keep bringing these hidden histories to light. Leave a comment below. Do you think Pierre was genuinely onto a new branch of physics in those dark séance rooms? Or was his brilliant mind simply blinded by the terror of the unknown? Until next time, keep exploring the legends.